I am Dr. Prince Sagai Sudherson, Associate Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today I am going to discuss about the problems on V-belt drive, which comes under the subject Design of Transmission System, subject code ME8651. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the student should be able to analyze the concept of design in the flexible drive elements like belt, chain and rope drives. The student should be able to develop the method of various types of gears with parallel axis. The student should be able to develop the method of various types of gears with inclination with the axis. The student should be able to explain the techniques used in industrial design, multi-speed gearbox application. The student should be able to categorize a suitable design for cam, clutches and brakes for automotive application. Belt and pulleys. V-belt are used in electric motors to drive blowers, compressor applications like mixer, grinder, etc. Machine tools. V-belt are made in trapezoidal section. The power is transmitted by the wedge section between the belt and V grooved in the pulley or sheave. Materials of V-belt. V-belt are made of cotton fabric and cords molded in rubber and covered with fabric and rubber. Advantages. Power transmitted is more due to wedge action in the grooved pulley. V-belt is more compact, quiet and shock absorbing. High velocity ratio up to 10 can be obtained. Disadvantage, it cannot be used with the large center distance. It cannot be used for large power. The efficiency of the V-belt is lower than the head of the fat belt. Types of V-belt. According to the Bureau of Indian Standard IS 2994 to 1974, the V-belt are classified as ABCD and E-type based on the cross-section of the V-belt. Specification of V-belt. V-belt are designated by the type and nominal inside length. For example, C2845 belt has a cross-section type C and has a nominal inside length 2845 mm. Disadvantage of V-belt. Design of V-belt drives. Design procedure. First step, selection of the belt section. So selection of the cross section of the belt depending upon the power to be transmitted, referred by the page number 7.58. Step 2, selection of the pulley diameter, small d and capital D. Select small pulley diameter D from the data book. Then using the speed ratio, calculate the pulley diameter capital D. This pulley diameter should be rounded off the standard diameter, referred by the page number 7.58. Section of center distance C. Select the center distance if not given from the data book, consulting the page number 7.61. Step 2. Determination of the nominal pitch length. So nominal pitch length L equal to 2C plus pi divided by 2 into capital D plus small d plus capital D plus small d the whole square divided by 4C. Step 3. Selection of the various modification factor. In order to calculate the design power, the following modification factors have to determine: length correction factor FC, correction factor of arc of contact, service factor. Then calculation of maximum power capacity. Maximum power capacity in kilowatt of V-belt using the formula given at the data book page number 7.62. Determine the number of belt. NB equal to P into FA divided by KW into FC into FD. Step 5, calculation of actual center distance. C actual equal to A plus root of A square minus B equal to A equal to L divided by 4 pi capital D plus small d divided by H, where B equal to capital D minus small d the whole square divided by 8, L equal to nominal pitch length. Example problem. Design V-belt drive to the following specification power to be transmitted. Following specification. Power to be transmitted 7.5 kilowatt. Speed of the driving wheel 1440 rpm. Speed of driven wheel 400 rpm. Diameter of driving wheel 300 mm. Center distance 1000 mm. Service 16 hours per day. Given data. P equal to 7.5 kilowatt. N1 equal to 1400 rpm. N2 equal to 400 rpm. D equal to 300 mm equal to 0.3 meter, C equal to 1000 mm equal to 1 meter. To find, design a V-belt drive. Solution, selection of the belt section. Consulting the data of page number 7.58. For power 7.5 kilowatt, B section is selected. Selection of pulley diameter, small d and capital D. Speed ratio is capital D divided by D equal to N1 by N2 equal to 1440 divided by 400 equal to 3.6. Small pulley diameter D equal to 300 mm. Refer the data book. Preferred smaller pulley diameter D equal to 315 mm. Large pulley diameter capital D equal to 3.6. D equal to 3.6 into 315 equal to 1134 mm. Consulting the data book page number. Preferred large pulley diameter capital D equal to 1250 mm. Then step 3. Selection of the center distance. Center distance equal to 1000 mm. Step 4. Determination of nominal pitch length. Nominal pitch length L equal to 2C plus pi divided by 2 into capital D divided plus D plus capital D minus small d the whole square divided by 4C equal to 4676.86 mm. For this nominal inside length and B section, consulting the data book and then take the nominal pitch length is selected as 4615 mm. Step 5. Selection of various modification factor. Length correction factor FC equal to, for B section, referring the data book page number 7.58, length correction factor FC equal to 1.14. Correction factor of arc of conduct FD equal to 180 minus capital D minus small d into C into 60 equal to 123.9. For this arc of conduct, consulting the data book page number 7.68, correction factor of safety is selected FD equal to 0.83. Service factor, consulting the data book page number 7.69, is light duty 16 hours continuous service for driving machine of type 2. Service factor selected FA equal to 1.3. Step 6. Calculation of maximum power capacity. Given as consulting the data book page number 7.62 for B section, power capacity formula KW equal to 0.79 S power 0.09 minus 50.8 divided by D minus 1.32 into 10 power 4 S2 into S. Utilize the formula, we will get the value 5.45 kilowatt. Step 7. Determine the number of belt NB. NB equal to P into FA into divided by KW into FC into F equal to 1.82, rounded value equal to 2 belt. Calculation of actual center distance. Actual center distance C actual equal to A plus root of A square minus B. A equal to L divided by 4 minus pi into capital D plus small d divided by 8 equal to 109278. C actual equal to 965.11 mm. These informations are referred from the book Machine Design Volume 2, Design of Transmission System by Jalaluddin, Machine Design R.S. Kurumi and J.K. Gupta, Design of Transmission System by T.J. Prabhu. Thank you.